In today's session, we are going to discuss about multiplexer as a part of digital electronics lecture series. A multiplexer is a device that several selects between several analog or digital input signals and forward the selected input to a single output line. It is also known as a data selector. That is, in a multiplexer, we can have 2 power n inputs, but the output will be only one. A multiplexer is a combinational circuit with 2 power n input lines and output will be one single line. This out of the 2 power n inputs, output will be selected based on the selection line. So we have a thing called selection line here. Along with the input and output, we have selection lines in the case of multiplexers. So have you ever think why multiplexer is being used? So here I've mentioned different applications of multiplexers. One is in communication. This is a broad category of applications. In communication systems, arithmetic logic unit, parallel to serial converters. And here, if you see here, I'm mentioned one application. Here, when we see a sound system, the inputs can be either from the MP3 player, or it could be from sound card of laptop, or it could be from digital satellite, or it could be from cable TV. These are different n number of sources, inputs. But you see the output is one, only one, the sound system. So here a multiplexer can be used in order to get the output from any one of these inputs. For that, we will be requiring the selection sources, whether MP3 has to be selected or laptop or satellite or cable TV. Yes, this is how even in the case of FM, radio broadcasting, we will be receiving n number of FM channels. But we'll be choosing any one, right? Either Suryan FM or Hello FM, right? Out of the n number of frequencies available, we'll be selecting one. One data will be selected. So for this purpose, multiplexer has been used. So different types of multiplexers are there. Few common multiplexers available are 2 is to 1 multiplexer, 4 is to 1 multiplexer, 8 is to 1 multiplexer and 16 is to 1 multiplexer. Here the 2 denotes the number of inputs and 1 is the output. 4 is the number of input, 1 is the output. So the number of input varies, right? But the output will be 1. Depending on the number of input, the selection line also will vary. If it is a 4 input multiplexer, then we require 2 selection line. That is, if we have 2 selection lines, then we can go for 2 power 2 combinations of inputs. Similarly, if we have 3 selection line, then we can go for 2 power 3 combination of inputs. So this is a 2 is to 1 multiplexer wherein 2 inputs are there, 1 output is there and we have a selection line. This is a very important part. We have a selection line. So this is a 2 is to 1 multiplexer. As we have discussed in the previous sections of adders and subtractors, if you see, for designing a digital system, first we need to write the conditions as truth table. Then from that we'll be arriving the Boolean expression through K-map or just by seeing, and then from the Boolean expression we'll be drawing the circuit which could be realized either in CMOS logic or TTL logic or any kind of logics we can realize it. So this is a 2 is to 1 multiplexer wherein if it is 2 is to 1 multiplexer, only one selection line is required, right? And we have two inputs are there. We have two inputs A0 and A1. Selection line is one selection line. So one selection line and two inputs. Output, if selection line is given 0, one of the input A0 will be selected as output. If the selection line is 1, another input A1 will be selected as output. That is why this is known as data selector. This multiplexer acts as a data selector only because of the selection lines. So after this we can write the Boolean expression just simply from this. This is S dash A0 plus S A1. If it is this is S which takes either S not S dash or S. So this is the Boolean expression and we have drawn the circuit diagram related to that. He will be having two AND gates, and here this is the inverted version of S. So NOT gate and one OR gate. Then we have the 4:1 multiplexer. So can you guess how many number of, if I could give four inputs, then how many selection lines are required? If I have dash number of selection lines, then four inputs is possible. So selection line should be two, right? If I need to give four inputs, if I want to select any one out of four inputs, then we need two selection lines. The same procedure is being followed here. We'll be drawing for the K-map for a 4:1 multiplexer. We'll be having four different combinations, four inputs we have given. So for the first combination 0, 0, 0, 0, 1, 1, 0 and 1, 1, A0 to A3, the data will be selected one by one. And for this we have written the equation. Here it is S dash, S1 dash, S0 dash, A0. This is S1 dash, S0 and A1, right? Similarly, for the four terms, we'll be writing the expression, and then based on the selection line, any one output will be chosen. We have realized this. This is an AND gate, a three input AND gate we do require. So this is another AND gate, this is another AND gate, this is another AND gate. So four AND gates are there. Here we have both S1 dash is also available, S0 dash is also available. So from S selection line S0 and S1, using a NOT gate, we'll be generating S0 dash and S1 dash. Then XOR gate, sorry, OR gate. This is a 8:1 multiplexer. For 8:1 multiplexer, obviously 8 inputs will be there and 3 selection lines will be there. And this is the truth table and circuit diagram corresponding to 8:1 multiplexer. This is for your assessment, and thank you.